In the beginning, God created the heavens and the earth. The Bible is unique among the documents of ancient history in positing an absolute beginning. The Bible boldly asserts that time is finite. In contrast, the Greeks and Romans of antiquity believed in the eternity of history. In the East, Hinduism and Buddhism imagine endless cycles of time, stretching into an indefinite past. For example, we learn from the Dalai Lama that there are multiple world systems in a constant state of coming into being and passing away. Now, the biblical writers didn't need to venture into this territory. They could have started with the Garden of Eden and left out the entire account of creation. Instead, the biblical narrative brazenly insists that the universe came into being at a particular instant in time as a voluntary act of creation by an eternal, supernatural being. Many modern scientists hold to the philosophy of materialism. The materialistic explanation of the universe is that everything is matter and energy and there is nothing else. Atheism is often a corollary of materialism, especially in the sense of denial of a supernatural personal God or any sort of higher creative power. Akin to the folly of Eastern religion and paganism, the atheist mythos has long contended for an eternal universe. A key doctrine of the atheist faith entails that if the universe is eternal, then it does not need a cause. Fortunately, science is not silent on this question. The second law of thermodynamics, or the entropy law, demands that the amount of usable energy in the universe is running down. Eventually, we know that the stars will burn out and the universe will suffer heat death. This means that the universe is winding down. Now, if it's winding down, it has to have been wound up. The universe is going to have an end. It had to have a beginning. There had to be a time when all the energy in the universe was usable. This marks the beginning of the universe. In addition, Albert Einstein's theory of general relativity demands that space and time had a beginning. This so troubled Einstein that he created a cosmological constant, or a cosmic fudge factor, to alter the clear implications of general relativity. He later called it the biggest mistake of his career because the cosmological fudge factor did not stand up to scientific scrutiny. In 1919, British cosmologist Arthur Eddington conducted an experiment during a solar eclipse which confirmed that general relativity was indeed true. No fudging necessary. The universe wasn't static, but it had a beginning. Eddington once wrote, "The idea of a universal mind, or logos, would be, I think, a fairly plausible inference from the present state of theory." Now, good scientific theories predict phenomena that have not yet been observed. Case in point, general relativity predicted an expanding universe, which would later be confirmed. In 1929, at Mount Wilson Observatory, astronomer Edwin Hubble made one of the greatest discoveries in history. He discovered that the universe is expanding at the same rate in all directions. Hubble observed the stars with a telescope and noticed they emitted a reddish light known as the Doppler effect. This meant that as time moves forward, the universe is growing apart. Now, it follows that if one went back in time, the universe would get denser and denser. Thus, if one goes back in time far enough, the universe would be contained in what scientists have called a point of infinite density, or singularity. Yet, a point can only be finitely dense. For a point to be infinitely dense, it would have to be non-existent. Therefore, all space and time came into existence from nothing a finite time ago. Now, in 1970, physicist Stephen Hawking and mathematician Roger Penrose wrote a famous paper that proved that given the truth of general relativity and the amount of matter in the known universe, the universe must have had a beginning. Hawking explains in A Brief History of Time. Hubble's discovery that the universe was expanding and the realization of the insignificance of our own planet in the vastness of the universe were just a starting point. As experimental and theoretical evidence mounted, it became more and more clear that the universe must have had a beginning in time. Now, returning back to our excursion through 20th century cosmological history, the atheist materialists dogmatically championed the eternal universe and what was called the steady state theory. In a vain effort to contest the theistic implications of general relativity and thermodynamics, steady-state theory argued that the universe was both infinite in size and eternal in duration. This required that new matter must be continuously created to keep the average density of the matter and usable energy equal over time. Atheistic materialist Fred Hoyle defended the steady state and, quite ironically, was the one that named the rival theory the Big Bang. He's quoted as saying that the Big Bang is an irrational process that cannot be described in scientific terms, nor challenged by appeal to observation. As was the case with general relativity, good scientific theories predict phenomena that have not yet been observed. Back in 1948, Russian physicist George Gamow came up with a new theory about the Big Bang. He decided that after the formation of the universe by a big explosion, a surplus of radiation should be left over uniformly spread throughout the universe. In the 1960s, two radio engineers working at Bell Labs, Arno Penzias and Robert Wilson, discovered some mysterious radiation coming from space. This radiation was not coming from a particular location, rather it was coming equally from all directions. In fact, it appeared to be coming from the universe itself. When the discovery was confirmed, it laid to rest any lingering suggestion that the universe is in an eternal steady state. Penzias and Wilson received a Nobel Prize for their discovery. Dr. Arno Penzias was quoted in the New York Times, March 12, 1978, as saying, "The best data we have concerning the Big Bang are exactly what I would have predicted had I nothing to go on but the first 5 books of Moses, the Psalms, the Bible as a whole." His partner Robert Wilson is quoted as saying, "Certainly if you are religious, I can't think of a better theory of the origin of the universe to match with Genesis." After finding the predicted expanding universe and radiation afterglow, scientists turned their attention to another prediction that would confirm the Big Bang. If the Big Bang actually occurred, scientists believe that we should see slight variations or ripples in the temperature of the cosmic background radiation. These temperature ripples enabled matter to congregate by gravitational attraction into galaxies. In 1989, the search for these ripples was intensified when NASA launched the $200 million satellite called COBE, or Cosmic Background Explorer. Carrying extremely sensitive instruments, COBE was able to see whether or not these ripples actually existed in the background radiation and how precise they were. Within 8 minutes, COBE confirmed the existence of this primordial background radiation and the very precise ripples that were predicted. In 1992, astronomer George Smoot, the COBE project leader, said, "If you're religious, it's like looking at God." University of Chicago astrophysicist Michael Turner was no less enthusiastic, claiming, "The significance of this cannot be overstated. They have found the holy grail of cosmology." Cambridge astronomer Stephen Hawking also agreed, calling the findings the most important discovery of the century, if not of all time. The Big Bang took place with the explosion of the point that contained all the matter and energy in the universe. It dispersed into the universe with incredible speed. Out of this explosion came galaxies, stars, planets, our sun, the Earth, and the laws of physics themselves were formed. Now, explosions usually do not bring about order. All observed explosions tend to destroy and disintegrate order. Now, if we were to find a very detailed order as a result of an explosion, it would only be logical to conclude that there was an intelligent intervention behind this explosion. Working as an astronomer for the prestigious Institute of Astronomy at Cambridge University, Dr. Fred Hoyle had staunchly opposed the Big Bang by championing the steady-state cosmology, until he was convinced by the overwhelming evidence. However, that was not the fact that led him eventually to an intelligent design position. Although he originally professed the atheist faith, Hoyle proved he was truly willing to follow the scientific evidence wherever it leads. Good scientific theories make predictions which are later verified by evidence. While trying to work out the way stars manufacture chemical elements, Hoyle observed that one particular nuclear reaction, the triple alpha process, which generates carbon, would require the carbon nucleus to have a very specific energy for it to work. The large amount of carbon in the universe, which makes it possible for carbon-based life forms like human beings to exist, demonstrated that this nuclear reaction must work. Based on this notion, Hoyle made a prediction on the energy levels in the carbon nucleus that was later proven by experiment. However, these energy levels, while needed in order to produce carbon in large quantities, were statistically astronomically unlikely. Hoyle later wrote, "Would you not say to yourself, some super-calculating intellect must have designed the properties of the carbon atom? Otherwise, the chance of my finding such an atom through the blind forces of nature would be utterly minuscule." Of course you would. A common-sense interpretation of the facts suggests that a super-intellect has monkeyed with physics, as well as with chemistry and biology, and there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question. Hoyle was an atheist until that time, and said that this suggestion of a guiding hand left him greatly shaken. Consequently, he began to believe in God. Now, with this in mind, let's examine the data from the Cosmic Background Explorer, or COBE satellite, once more. COBE not only found ripples, but very precisely finely tuned ripples. The ripples show that the explosion and expansion of the universe was precisely tweaked to cause just enough matter to congregate to allow galaxy formation, but not enough to cause the universe to collapse back in on itself. Any slight variation one way or the other, and none of us would be here to tell about it. In fact, the ripples are so exact, down to 1 part in 100,000, that COBE project leader George Smoot called them the machining marks of the creation of the universe, and also the fingerprints of the maker. This fine-tuning clearly points to intelligent design. There are many such factors in the fine-tuning of the universe, as Oxford mathematician John Lennox explains.
More and more has been discovered by physicists and cosmologists that give evidence of a universe that's very finely tuned. That is, certain of its basic properties, the fundamental constants that govern what the universe is like, have to be within very, very finely defined limits in order to have a universe like we have, on which carbon-based life is possible. And we call that the fine-tuning of the universe. For example, the ratio of the electromagnetic force to gravity in the early universe has to be accurate to about 1 part in 10 to the 40 in order that we can have the chemistry of the universe as we now see it. Now, 1 part in 10 to the 40, to get some idea of that, let's imagine that we covered, say, the whole of Russia with small coins, and we built the piles of coins over the whole of Russia to the height of the moon. And then we took 1 billion systems like that, and we painted one of the coins red, and we asked you to blindfold a friend and go and find it. They'd have got about 1 chance in 10 to the 40 of finding it. So it's a very small probability.